With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question is saying that in a box, right? So in a box, mixture containing H2, O2 and CO, right? So in a box, there is a mixture, and in this mixture there is a H2, O2 and CO gases are present, right? So with the charcoal, right? So with charcoal. So now we have to tell that the variation of pressure with time will be. So here these are the graphs. So we have to find out the what will be the nature of graph, right? So we have to find the variation of pressure with time, right? So let's see it. So let's see actually what is happening here. So we have a mixture, right? So that means let's say this is a charcoal, right? So let's say this is charcoal here, right here. Let's say this is charcoal in the mixture, right? So this is, you can say this is a box, right? So this is a box, right? So I can say this is our box, right? So in this box we have a gases, right? So in this gas box we have a gas. Let's say this is our gases, right? So this is our gases mixture, right? And in this mixture we have a gas like H2, we have a gas oxygen O2, and we have a gas carbon monoxide, that is CO, right? So that means finally at the initially the pressure is very high, right? So initially the pressure is very high. So that means we have a graph between pressure and temperature. So I can say this is pressure axis and this is temperature axis, right? So I can say that this is our time, right? Not temperature, this is our time, right? So as the time passes, and this is pressure, right? So this is time, and this is pressure, and this is time, right? So at the initially, right? So when t is equal to 0, let's say t is equal to 0, so we have a high pressure, right? So we have a high pressure, right? So we have a high pressure, let's say it is here, right? So this is pressure, you can see here, this is our pressure, right? So you can see here, this is charcoal, right? So this is charcoal, right? So this is charcoal, and here we know that charcoal has a surface area. That means there is a possibility of adsorption of the gases. That means adsorption is, and you know that adsorption is a surface phenomena, right? And actually what will happen in the case of adsorption, these gases, right? So these gases molecule will adsorb on the surface, right? So through the van der Waals interaction, right? So they have a particular site. So let's say these are the sites, vacant sites, right? So in the case of this is the charcoal, right? So the H2, the molecules of H2 come here, molecule of O2 come here. So that means they are adsorbed, right? So they are adsorbed on the surface of charcoal, right? So that means initially as the time increases, or you can say as the time passes, the pressure decreases, right? So the pressure decreases like this, right? So the pressure decreases, right? So like pressure, you can say the pressure decrease, right? So this pressure decreasement, the decreasement in this pressure will continue until these sites are occupied. Once they becomes occupied, right? So once they becomes occupied, let's say this becomes occupied, right? So they becomes occupied, right? So that means there is no possibility, or you can say there is no vacant site. That means these gases will not adsorb on it. That means they are free to here, right? So they are free to here, right? This means there is a pressure, right? So that means after this particular point, the pressure becomes constant, right? Becomes constant, right? As the time passes, right? So due to the fulfillment of this vacant site, right? So this should be the graph, right? So let's check the option, right? Option A is saying this, as the time passes pressure becomes constant, right? So this cannot be our right answer, because as the time passes adsorption takes place, and due to the adsorption pressure decreases, right? So pressure decreases, right? So I can say due to as the time passes pressure decreases, right? As time passes, right? So I can write as time passes, right? As time passes pressure decreases, right? So this cannot be our answer, so we cannot get a straight line, right? So now question here is option B is saying that pressure decreases linearly, right? So this cannot be decreased linearly, right? So this can be, you can say this is you can say this is not linearly, this is like graph like this, right? So this is a graph like this, right? So it is like this, right? So here the graph is like this, right? So this is not linearly, right? So graph is like that. After a particular point it becomes constant, right? So it becomes constant due to the fulfillment of the vacant site, right here, and this is not linear, so this cannot be our answer, right? So yes, option C seems to be correct. Option C is the correct, right? So here you can see the graph is like this, right? So and option D becomes wrong. It becomes wrong because here you can see pressure is very low, and in the option, and we know that in the starting case when time is equal to 0, pressure is very high due to the presence of this gas, right? So when after the time passes, so the adsorption takes place, so the pressure decreases, right? So but here you can see that pressure is increasing, right? So pressure is increasing, so this cannot be our answer, right? So the correct answer, we are left with the correct option, that is option C, in which pressure is decreasing not linearly, and after certain point it becomes almost constant, right? It becomes almost constant. So I can say option C will be the correct answer, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.